Hey, this video is also about ionic compounds and naming them. But we also have some special cases where we have metals in the transition group and we have something called polyatomics. And we're going to learn how to name ionic compounds using transition metals along with polyatomics. We're also going to learn how to write the name and the formula. So for this video, make sure you have your periodic table out, as well as your list of polyatomic ions. Okay, to start with, we're going to talk about what a polyatomic is. And a polyatomic is really a group of two or more atoms that are covalently bonded together, okay? Or they're of a metal complex, but they act as one unit. And they are an ion. Okay, so we call it polyatomic ion, many atoms ions. So they behave as one thing. So you can treat them as if they are one atom, like they're glued together and they can't be broken apart. And you can identify polyatomics. If you look at your polyatomic sheet, you can see that they usually, okay, there's some exception to the rule, if you want to look at the name of a formula, a name of a compound, if the name ends in ATE or ITE rather than IDE, then you know it could have it has a polyatomic in it. If your formula has the total formula has 3 or more capital letters, okay, so the whole formula has 3 or more capital letters, that helps you identify that there's a polyatomic there. And you can see that this is a regular nonmetal, okay, that became an ion. These are examples of polyatomics. And note that they all have the same oxidation number of -1. So if you look at your polyatomic sheet, okay, you have to be able to understand how it's organized. Now, if you're looking at my green polyatomic sheet, you can see that they are organized by oxidation number. So just to give you an example of what your table of anions and cations looks like, this is just a little subsection of your table, but you can see it's organized by the oxidation states. So the top of your paper will have the -1 polyatomics. Okay, and if you notice, most of them do end in ATE or ITE. Now there's a couple that you have to recognize that are important that you'll see a lot. And one of them I want you to highlight on your sheet is hydroxide. Okay, it's a little lower down, but hydroxide is OH with a -1. It is also a -1 polyatomic. But you can see that a lot of people get confused because it ends in IDE rather than ITE or ATE. Also make note of ammonium. Okay, ammonium is the only polyatomic with a positive charge that you need to know, and this is at the bottom of your sheet. So it is NH4 plus 1. You'll find that on your sheet. Make sure you highlight that. These two are the most common and most widely used polyatomics that you'll see that don't follow the typical pattern. So just to repeat, hydroxide is a very important polyatomic that you must recognize. It's got a -1 oxidation number and its formula is OH. And ammonium, NH4 plus 1, is also the only positive polyatomic that you will probably use in chemistry. So let's start by writing the formula from this compound, okay? So we first look and we see aluminum, and we know aluminum's a metal, so we're going to follow our formula rules for writing a metal. step one, write the metal symbol first. Okay, so that would be Al. Second step, as we did in the video before, is to write the oxidation number. We know that aluminum always has an oxidation number of +3. So now we've done step one and step two. The third step is to look at the ending of the second element, and it ends in ATE. So if it ends in ATE, it is a polyatomic. And you must look up that polyatomic on your reference sheet if you don't know it by heart. Okay? And carbonate is CO3, and it has a -2 oxidation number. So now we've got the oxidation number for the polyatomic. Now keep in mind that this polyatomic is stuck together like glue. So this -2 is for the whole thing. Next step is just like simple ionic, where we're crisscrossing just the numbers to get the subscripts. So the 2 and the 3 are crisscrossed down. Now, what you've got to be careful of, because CO3 is stuck together like glue, we've got to reflect that when we crisscross, when we write the numbers below, that this 3 that we've found is on the whole carbonate. Not just the carbon, not just the oxygen 3. It's on the whole thing. So we must use parentheses for polyatomics. And as always, we have to reduce subscripts if we can. But in this case, this is the final formula for aluminum carbonate. Okay, now we're going to name the compound. Okay, so the first thing when we look at it is you see Rb, and we know that's a metal, that's rubidium. And then we count the capital letters. Oh goodness, there's more than 2. So that means there's got to be a polyatomic here. So the first step, we write the metal name just like we did before. So that's rubidium. Okay, now we look at the second part. Is it just a nonmetal? No, it's not. It's a polyatomic. So now we have to look up the polyatomic and write the name. Okay, well, they're in alphabetical order on our polyatomic sheet. We find out that NO3 is nitrate. And that's it. Rubidium nitrate. Okay? Now, we've finished with polyatomics. Now we're going to talk about what if the metal, the front part, is from one of the areas that has more than one ionic charge or oxidation number. Okay? If we find out that it has more than one oxidation number, we need to put that oxidation number in a Roman numeral. So you can see in blue, a lot of the ones in blue have multiple oxidation numbers. That means when we write that metal, we must put parentheses with what oxidation number we use. So for the oxidation numbers, you can look at your blue periodic table to see what the possible oxidation numbers are. So for example, if you look at iron could be an oxidation number of +2 or +3. So that's why we have to write Roman numerals. Okay, if you look at vanadium could be a +5, or no, excuse me, that +5, +4, +3, or +2. So that's why we have to write parentheses. Now, notice this is the transition. These are the inner transitions right here. You should know that from this is transition. Those are the inner transitions. But over here, notice lead and tin and antimony. These are, they still, even though they're not in the transition group, they still have more than one oxidation number. So you need to make note of especially lead and tin. You'll see them a lot. And you have to recognize that they do need parentheses. Okay, well, let's write the formula when given a metal that's a transition metal, okay? Well, this is actually not too bad because look, the Roman numeral gives us the parentheses. Excuse me, the Roman numeral gives us the oxidation number. And let me take a minute before I start, write out Roman numerals and how they look. Okay, some of you may not be familiar with Roman numerals. Okay, well, we're going to write 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, 1 in Roman numerals is just 1 slash. Easy. 2 in Roman numerals is 2 slashes. 3 in Roman numerals is 3 slashes. So far, not bad. I'm going to skip 4 a minute and go to 5. 5 is a V. Okay. Now 4 has a 1 before the V, meaning 1 less than 5. 6, I bet you could guess, would be a V and a 1. 7 would be a V and a 2. And 8 would be a V and a 3. And if you want to continue, not that you will need it for valence electrons, but 9, let's skip. 10 is actually an X, and 9 is actually a 1 before the X. So these are our Roman numerals that you need to know for writing inside the parentheses. So let's go back to our problem. First, we're going to write the metal symbols first. Okay, so we have iron. So we know iron is Fe. Next, we're going to get the oxidation number for the metal from the periodic table. Well, since there's already parentheses, we know that we're going to get the oxidation number from the Roman numeral. And 3 slashes is 3, so the oxidation number is +3. Next, we're going to look at the second part of the formula. Okay, we look at the ending and we see that it's got an ACE. That means it's a polyatomic, so we've got to look at our polyatomic sheet. And we find that nitrate is NO3, and then we get the oxidation number off our polyatomic sheet, and it's a -1. Next, we crisscross, remembering that we use parentheses for a polyatomic if there's more than one. Okay? And remember to crisscross just the number, not the sign. We don't write the 1, but NO3 still needs parentheses, and the 3 goes down here. And that's our final answer for iron 3 nitrate for writing the formula. Okay, now let's look at this one. We're going to name the compound. First of all, you're going to write the metal name as the first part of the name. Okay, so let's first do that. And that is Cr in chromium. Now, before I go anywhere, I actually do step 3. So I look at chromium, I find it on my periodic table, and I determine whether it needs Roman numerals. And I see that chromium, if I'm looking at the table with the oxidation numbers, has 3 different oxidation numbers. So I know that it needs parentheses. So I leave a blank so I don't forget to fill in that number for the parentheses. Okay? Now I'm going to look at the second part of the name. I see a lot of capital letters, so I know I got a polyatomic there. So I'm going to look up that polyatomic, and I find that it is acetate. Now I got to figure out what Roman numeral is going to go next to chromium. What's the oxidation number? So what I do is I work in reverse from the formula to see what the oxidation number should be. I take the 3 and I bring it back up, +3. There would be a 1 here, and I bring it back up. That would be a -1. And I see the acetate, yes, is a -1 oxidation number, so chromium must be a +3 oxidation number. And I put the 3 in the parentheses. Okay, and we'll do some harder ones later, but that's the end of this video, and looking forward to seeing you soon.